Okay, welcome back. We're going to continue our discussion on week 2 material. And if you remember, I wrote the word ions in the agenda for the week. So that's what we're going to focus on right now is ions. So okay, sometimes my tablet takes a second. I think it's confused, just like I am. So we're going to look at ions. Okay, I guess all right. So what are ions? Okay, an element, okay, is made up of atoms or atom. For now, let's just atoms. Okay, and then when the atom gain or lose electrons, the element carries a charge. It can be positive or negative. We never say an atom is charged or charged positive or negative. It always is the element. So for instance, let's take sodium. I believe the sodium's atomic number is, if I could bring up the periodic table, sodium's atomic number is 11. 11, right? That means it has 11 protons and 11 electrons, right? Now you don't have to do the electronic configuration every time to arrive at this. I am just doing it just once or twice just to tie the idea of Roman numerals to the atomic number to the ions. So I'm going to write the correct electronic configuration here. It's 1s2, 2s2, 2p6, 3s1, right? And as I said, the last orbital in the sequence is your valence, right? In accordance with that, I'm just going to box my 3s because that's a sole outlaw and no one is with him or her. All right. So if you also look under the periodic table, the column where sodium is labeled 1a, right? And sodium is a metal, right? Sodium is a metal. That means it can only lose one electron, because I think I explained it very clearly when I explained the valence orbital and valence electrons. The valence electrons are the ones that are available for use. That is, it can only be lost or gained because sodium is a metal, and metal only tends to lose electrons. I don't know of a metal that gains electrons. So it's almost always it loses electrons. So how many electrons can it lose? It can only lose one. So sodium is +1. Now this right here is a ion. Is it simply an ion? Well, we can call it by another name, which is, let's get a blue. Positive ions. Positive ions are known as cations in chemistry. So sodium +1 is a cation, because it's positively charged. Now, do you have to every single time write the electronic configuration and do exactly what I did? It's like that Newton's dog, where every time, or I believe a rat or whatever, that every time he rang a bell, it asked for a cookie, whatnot. You don't need to do it just because I did it once this way. That is why I'm explaining the chemistry here. So let's go pick a different element. Let's pick say vanadium. Vanadium is 24. Vanadium, let me bring it back. Vanadium is 23 and 5b, right? Vanadium is 23 and 5b. right? Okay. This means, and vanadium is a metal. Okay. In a nutshell, you do not have to write the entire electronic configuration to figure out what ions would it make. Remember, I said this is 5b. So, vanadium is a metal, so it can lose up to plus 5 electrons. So, vanadium plus 5 is the maximum it can have, all right. But if you do write the electronic configuration, that means you will see 1s2, 2s2. I am writing the corrected version here. I am not writing the uncorrected version. So, 3s2, 3p6. I believe vanadium is 1, 2, 3. So, it is 3d3, 4s2. This is obviously the flipped and corrected version, and that means it can lose all of this 5, which is what the 5b corresponds to, or it can just lose the 2 first and then it can lose the 3. That means vanadium can technically have plus 2, vanadium can be plus 3, or it can have the full plus 5. Okay? This is like you can press your accelerator and go 40 miles per hour, or you can go 60 miles per hour, or your car might have a maximum of say 110 miles per hour. Okay? You don't get 3 different accelerator pedals, you get only 1. Okay? That means 1 is the vanadium metal itself. It can go at 40 miles per hour, that means you can lose just the 2 in the outermost one right here, or it can lose the 2 and then 1 here out of this 3, and then it can make 3 or 4 or 5. Okay? But it can only lose a maximum of 5. So, V plus 5 plus is a cation because it is positively charged, and metals only make cations. I don't know of an exception where I can think of a metal being a negatively charged species. I have yet to come across, but if any of you have come across a metal with a negative charge, please post it in the comments. This is for people outside my class, that if you're still watching my videos, if you know of a metal that is negatively charged, please feel free to let me know. All right, so let's go back and look at a different one, and I think I'm going to use the example that I've already used, which is oxygen. Okay, oxygen's atomic number is 8. Okay, and if you notice, it's in group 6A. Okay, and with nonmetals, oxygen is a nonmetal. If you noticed, it's within that black band I drew, and nonmetals typically gain electrons. Okay, gain electrons. Okay, that means how much can they gain? Well, 6 is not something it loses. I've made that very clear. Okay, it has 8 is a magic number. Okay, 8 is a magic number, also known as an octet. Okay, means all things would have to gain only 2 more or 3 more or 4 more, however many it has to gain to get to the 8. So, to go from 6 to 8, it needs 2 more electrons. Okay, that's when it becomes 8. Okay, don't worry about the A or B, but if it is 6 and if it's a non-metal, it will need 2 more to get to 8. That means oxygen will gain 2 minus. Okay, see, I didn't even write the electronic configuration, it's that simple. Okay, now if I pick fluorine, okay, fluorine I believe is 9. Okay, and it's in 6, 7A. Okay, and to get to 8, which is the octet, how many does it need? It needs only 1 more electron. Okay, so that means it is F1 minus. Okay, now same thing with nitrogen. Nitrogen I believe is 5. Okay, oh, sorry, I believe it is, yeah, nitrogen 7. I'm sorry, I was thinking of another element, so I was overthinking myself there. Nitrogen 7, Okay. That means, no, sorry, nitrogen is, I believe I wrote it right first time. Okay. Nitrogen is 7, but it is 5A. That's exactly what I was trying to do. Okay. And to get to 8, okay, it needs 3 electrons. Okay. That's why N is 3 minus. Okay. These are pretty standard. Okay. I don't know of any exceptions to it, like nitrogen being N4 minus, F being F2 minus. Okay. And this is how we end up with things. And if you always see, all right, I'm going to show you something, even though this is a kind of a foundation for future learning. Remember, we said sodium, okay, is in group 1, right? So it can only lose 1 electron, right? And fluorine is in 7A, so I said it can only gain 1 electron, right? Now, we've all heard of sodium fluoride. I think fluoride is a common sodium fluoride. Don't worry about the naming. This is something we will learn in greater detail at some other point of time. Okay, sodium fluoride, any fluoride salt, is a common ingredient in toothpaste. Okay, common ingredient in toothpaste. It may be a different type of a fluoride salt, but common ingredient in toothpaste. Okay. Now, if you've seen a toothpaste and you see sodium fluoride, well, sodium is, to write the formulae for it, again, this is just kind of a teaser, if you would call it, sodium. Okay. All we do is take this one, put it over here, take this one, put it over here. If it is 1 to 1, you don't need to write anything, just leave it be. This is how we end up with the formulae for sodium. Okay, let's take, say, calcium. Calcium is in 2A, right? This is in 2A, so it will be, it's a metal, so it can only lose +2. And let's say fluorine. Fluorine again is in 7A, so that means it can only gain 1 more, so it's 1 minus. Okay, say instead of the company that is making your toothpaste not want to use sodium but calcium fluoride, which makes sense because your teeth needs calcium, and fluoride is also an ingredient that helps you keep stronger teeth, and this is also a common ingredient in toothpaste. Okay, calcium fluoride. Okay, you see, I make the difference between fluorine, which does not have a charge, and fluoride, which has a charge. Now, how do we end up with the compound? Well, this won't be a question on your quizzes, I promise. This is something of a teaser that I'm bringing ahead of time, so you kind of seem to make sense of these things. So this is not balanced. To arrive at the compound, you put the 2 here and the 1 here. Okay, whenever it's 1, you do not have to represent it. So it's CAF and the 2 goes here. That right there is the formulae for calcium fluoride. So a company that making a toothpaste could opt for both sodium fluoride and calcium fluoride. It doesn't hurt it. I've seen companies use more calcium fluoride than sodium fluoride. Okay, just keep this in mind, because I am tying why this +1 or -1 or +3, +4, why does it all matter, is because you need to know how compounds that's contained in our daily food products or cosmetics, how they have a formulae. They just give you the name, but if you are curious, you can see how many you can do on some of your Lay's chips bottle or whatever. All right, so let's go back. And so the summary here is metals typically make positively charged ions. Okay, these are known as cations, and non-metals, okay, typically make negatively charged ions. and these are known as anions. Okay, cations means they lose electrons, and anions means they gain electrons. Okay. All right. With that said, keep this in mind. Now we're going to write, I believe I have shown you an electronic configuration for an anion, but we're going to redo electronic configuration for an ion, both cations and anions, before we conclude the week sequence with our periodic trends. All right, stay tuned. I'll be back with a fresh screen.